So in February 2026, Mistral has released Voxtral Transcribe 2, and it is the latest speech-to-text model family released by Mistral. And as a part of this model family, two models have been released. One is Voxtral Transcribe 2, which is used for batch generation, and Voxtral Realtime, it's used for very low latency streaming. So what is the difference between these two is, for a Voxtral Mini Transcribe V2, it is designed for offline or batch audio. So you take full audio files or long chunks of audio files before decoding, and then you convert it into text. So this allows more for a global context and search, and it also supports things like diarization and timestamps. And it is used for use cases like meeting transcriptions, podcasts, and recordings. And Voxtral Realtime, it is again designed for live streaming audio. So it processes speech incrementally as the user speaks, and it keeps emitting partial transcripts continuously. And as you see here, we can see the latency is configurable down to 200 milliseconds, and it is incremental decoding of the speech. And so, but the disadvantage with real time usually is that accuracy of the transcription is slightly lower than the offline batch models. And this is typically again used for voice assistants and live captions and conversational agents and also dictation. So these two models, again, they are released under Apache 2 license, which is you can deploy it on your own servers, and you can also customize it. Yeah, so like we have discussed, Voxtral Realtime, it is basically built for live applications. And we see the transcription performance on the FLEURS benchmark. The FLEURS benchmark, it stands for Few Shot Learning Evaluation of Universal Representations of Speech. So it is a huge multilingual speech data set. It almost covers 1 or 2 languages with about 12 hours of speech per language. And it is designed to evaluate speech recognition and cross-lingual generalization. So unlike just English-centric datasets, FLEURS measures how well models generalize across languages and with various accents. So you can see that Voxtral Realtime performs quite well on various languages. If you see here, Italian, Spanish, Dutch, Chinese, so that there are different languages, and the word error rate is shown here, and the lower the word error rate, the better it is. So before we discuss the performance of Voxtral Mini Transcribe 2 and also the real time, let's see the main features that came with this update. So the first one is speaker diarization. So diarization, it means identifying who spoke when in an audio stream. So this diagram shows how speaker diarization works inside a modern speech-to-text system. This process has 3 main stages. So the first stage is the voice activity detection. So the first stage is voice activity detection, and the model, it separates regions containing speech from silence or a background noise, and it produces clean speech segments that will be analyzed further. So it is kind of like cleaning the data before training a model. The stage 2 is speaker embedding and clustering. So each speech segment is converted into an embedding, and a speaker embedding, it's more like a numerical vector that represents vocal characteristics such as pitch patterns and articulation style. So segments spoken by the same person, they produce embeddings that lie close together in the space. It's just like word embeddings. And then clustering algorithms are used to group these embeddings into distinct speaker clusters, effectively discovering how many speakers are present and which segment belongs to which speaker. And the third one is obviously the speaker assignment. So finally, the clustered speaker identities, they are aligned with the transcript timeline. So each speech segment receives a speaker label and a timestamp. So the result again is a structured transcript that indicates who spoke and when, enabling multi-speaker conversations. Voxtral Transcribe 2 supports context biasing, the ability to guide transcriptions towards specific words or phrases. So you can provide up to 100 biased terms such as names, product terminology, or domain-specific vocabulary that standard speech models often misrecognize. So this is particularly useful for proper nouns in technical language where ambiguity is common. And if you see, this diagram shows how context biasing guides a speech-to-text model towards correct domain vocabulary during decoding. So the key idea is that the model considers many possible word sequences, and biasing increases the probability of sequences containing the expected terms. Now, for example, the spoken phrase is "we deployed Voxtral on Kubernetes" may produce candidates like "we deployed Voxel on Kubernetes" or "we deployed Voxtral on Kubernetes." So both are candidate hypothesis, which means that both are the possibilities for the spoken audio. Now, because they sound similar, the decoder often considers the both common and domain-specific words. So, if you see here, since we have already mentioned the bias terms like the Voxtral and Kubernetes, the model will guess the second option, the second candidate hypothesis, and it will boost its score. So the correct transcription will be "we deployed Voxtral on Kubernetes." Context biasing works by nudging the decoder towards expected vocabulary, and it improves recognition of names, brands, and technical terminology without having to retrain the speech model. So apart from speaker diarization and context biasing, there are also other features like word level timestamps and which can be used for subtitle generation and audio search. Like we have discussed audio search in another model on Voxtral, which you can see above. Apart from this, there are also other features like noise robustness, like they maintain transcription accuracy even in very challenging acoustic environments such as factory floors. And there are 13 languages supported, including Hindi, and you can transcribe up to 3 hours of audio recordings in a single request. So you can also test these models in the audio playground, which we will be doing in this video. So the main applications of these models are for transcriptions during meetings, and also to build voice agents and virtual assistants, and also in other areas like media and broadcasting, and also domain specific regions, because now we have context biasing and we don't have to worry about the model not getting the domain specific words right. And so since these models are available as open weights, you can also deploy them on your own private cloud premises, or you can directly use the API, which is now priced at like $0.003 for Mini Transcribe V2 and double that amount for Voxtral Realtime. Now we are in the AI studio where we can test how these models work. So let's first test the offline Voxtral Mini Transcribe V2. Let me upload a file. As you can see, the audio file has been transcribed, and you can hide the waveform here if you want. And then let's just play the file and see.
Don't worry about it, but maybe I will fill out one of those suggestion cards after all. You need to rearrange your store and hire more people.
Sounds good to me. Good luck finding that book.
Thanks.
You're welcome. Okay, who's the next person in line?
Now get ready to answer the questions. You may use your notes to help you answer.
So as you can see, there are 3 different speakers in this audio, and here speaker 1, speaker 2 and speaker 3. So they have been labeled properly whenever they speak, like just like how we have discussed in the diarization explanation. And even the timestamps of the speech has been marked correctly. So this is the batch transcription model. Now let's just start over and see how the real-time model works. You can just go to real-time and then I will start speaking. Hi, how are you? Is this the Voxtral real-time model? And could you also please tell me how it works in a much detailed manner? So you saw how it's transcribing as I'm speaking. And if you see, it's also correcting the mistakes it makes. So first of all, so initially it started with manner as in MANOR, but then again it changed it to MANNER correctly. So this is how the Voxtral models that have been released work. And I have stop recording, and you can also copy this transcript or you can start over. I've also made a very detailed video on the Voxtral model and its technical architecture, which you will find here. Thanks for watching.